This conference will now be recorded.
Welcome to Lesson 3-6, Example 1. A linear regression is a method used to calculate the line of best fit. The line of best fit is the trend line that most closely matches the data. In order to find the line of best fit, we need to take the table and we're going to enter the data into the graphing calculator, or in this case, Desmos. So the question we're going to be answering is, what is the equation of the line of best fit for the data in the table? So step 1, we're going to enter the data into a graphing calculator. So first of all, I'm going to switch over to Desmos. You know what? I'm going to start all over so that you can see where I go. So www.desmos.com, and then I'm going to choose graphing calculator. And now I have to enter my data. So I'm going to go over here to the plus, the add item. I'm going to click on that, scroll down and select a table. And now I'm going to enter in my data. Okay, my X values are 1, 2, 5, 8, 9, and 17. And my Y values are 30, 55, 75, 120, 145, and 250. Once you have your data in, once you have your data and a table created, we could go over to the graph and see what the scatter plot looks like, but we don't need to do that for this. We just need to find the equation of line of best fit. So underneath it, underneath my table, I'm going to click and I need to find the linear regression. Now, normally I would use y equals mx plus b. However, in this case, my x's are not just plain x's, they are x sub 1s, and my y's are y sub 1s. So I'm not going to say y, I'm going to say y sub 1, and I'll just type in y1. Now, instead of an equal sign, I'm going to do a tilde, which is a shift and then the key next to the 1. Y is approximate, and now I'll type in mx plus b, except it'll be m, and then instead of x, it's x sub 1, because that's what my x column was titled, plus b. And we have our correlation coefficient. So, and we have our line of best fit. M is our slope, so I'm going to write that down in my notebook. M equals 13.558. B is 17, my y-intercept, 17.5882. And now I'll switch back. And the last step is to write the equation of the line of best fit. Y equals 13.56x. I go to the hundreds place. You can go to whatever decimal position you prefer. So 13.56x plus 17.59. And that would be our line of best fit, our linear regression. Let's look at our second example. Example 1b. Here's a table. What I'd like you to do is to pause the video, go into Desmos, type in your table, and come up with your line of best fit. Pause the video now, do that, and then restart your video. Okay, I'm going to close this out and start all over again. Leave page, open, Desmos. And the reason I do that is so that you can see how I do it. Okay, I'm going to add a table. And it is 1, 2, 4, 5, 7, 8, 9. And my y values are 5.4, 6.1, 8.1, 8.5, 10.3, 10.9, and 11.5. Then to get I'm going to click below and I will do my linear regression, y1 tilde mx1 plus b. And my equation would be, my slope is 0.776823. My y-intercept is 4.69062. And I'm just going to verify that my table is correct. 5, 4, 6, 1, 8, 1, 8, 5, 10, 3, 10, 9, 11, 5, 4, 5, 7, 8, 9. Perfect. Okay, and then I'll go back and write my equation. Y equals 0.78x plus 4.69. And that would be my line of best fit. Thank you.